All right, a little extra practice for your quiz tomorrow. So, first up, probably one of the hardest ones actually that's on your quiz. Find alpha such that alpha is the arctangent of I don't know why I put 8 radians in there. That needs to be fixed. That doesn't make any sense. Of just negative 3.45. So you have a tangent ratio of negative 3.45. So that's fixed. You won't see that glitch. Over the interval from 0 to 2 pi. So there's probably more than one answer because, we've been memorizing these circular concepts here. There's usually more than one answer. Now, first thing we're going to do is we're going to see what our TI-84 says. And we'll work with degrees and we'll do a conversion later. All right, so we're going to hit, make sure I'm in degree mode. I am, cool. And hit second tan negative 3.45. And the calculator says negative 73.84 degrees. So by my TI-84. I have negative 73.84 degrees, which is not valid because that does not lie between 0 and 360. So that's not valid. Hopefully you understand why I'm saying 360. So that ain't it, but it's drawable, right? It's something I can draw. I don't want to mess this thing up too much. That angle would rotate about like this, and it would be 73.84 degrees of positive rotation. Now, this is a big deal because that angle is formed with the x-axis, and that means it's a reference angle. All right, now, let's talk about ASTC. This number is negative. According to ASTC, tangent is negative in those two quadrants. So this is definitely one of my answers, all right? Let's think about the positive rotation to the same location. That is everything of a circle but 73.84 degrees. So I'm going to figure out that my alpha here is 360 minus 73.84. I done forgot what I was thinking. Let's make sure I do this right. So it's 286.16 degrees. Now I'm going to have to convert that to a radian at some point in time, but I'll just do that later. Notice how I want it to be a radian up here. So this is going to have to be made a radian, but I'll do that later. Now, what I did is I took care of the angle that was in this quadrant. So now I'm going to think about the angle that's in this quadrant. Here's a reference angle. Reference angles are always formed with the x-axis. So this is also 73.84 degrees. This other alpha, we'll call it alpha 2, is the straight angle of 180. Take away what you have, 73.84. So that's going to be 6.16 degrees. Seems right. You can push buttons and check me. That's fine. Now, they both have to be turned into a pi rad. So to take a degree and turn it into a pi rad, we have to do some stuff. We're going to multiply it by pi over 180 in both situations here. And that's going to be done in a TI-84. I'm obviously not going to do that in my hand. So here's this one here. So that guy is about 4.99 rads. All right, the other guy here, which was the 106.16. Again, we're going to multiply it by pi, divided by 180, and it's about 1.85 rads. One of my answers, one of my other answers. Not a bad problem if you're me. If you're you, I don't know. This one is something that everybody should get, but it has historically had a really bad rate of success, and I don't know why. Solve the right triangle fuzz. I'm going to do the easiest thing I can do, which is this piece right here. That's the oldest theorem that we as a species have. A squared plus b squared is c squared. Not hard. 4 squared is 16, right? 8 squared is 64. Last I checked, 64 minus 16. I think that's what gets most of y'all is 48. So A is going to be the square root of 48. Now, 48 is a root of 16 times the root of 3 because 3 times 16 is 48. Crazy, huh? It is. So it becomes 4 root 3. Now I'm going to pick one of my angles. All right, I can either do F or U. You decide. I'm going to go with angle F. All right, so 4's relationship to angle F is opposite, and 8 is the hypotenuse. That's the sine ratio. The sine of angle F is 4 over 8, which is cool that it ended up being that way. And it just occurred to me, I made this thing up, I didn't even realize at the time, but I already know what it's going to be. Do you? It's going to be 30 degrees, isn't it? But anyways, that means that the measure of angle F is the arc sine of 4/8, which is a half, by the way. If it wasn't for the fact that this is meant to be a button pushing problem, I would have simplified the fraction. And I get 30 degrees. So that's 30. Now, a triangle has 180 degrees. So this guy right here has got to be 180 minus the 90 minus the 30, and that's 60 degrees. Not a hard problem. All right, select all angles that are coterminal with negative 3 pi over 3. Now, the easiest way to do this is to simply add or subtract 2 pi, because 2 pi is 360 degrees, and that has not clicked with enough of y'all yet. For TJ, it's ridic that it has not clicked yet. Ridic. Daggum, kids. Not a hard concept. Now, I'm not going to bore you with doing this by hand. I'm going to take negative 31 over 3, and I'm just going to add 2 until I see an answer. All right, so I haven't done a convert to a fraction yet, but there's a negative 19 pi over 3. Cool, there's a negative 13 over 3. Negative 7 over 3. I don't see a negative 7 over 3. I see a positive 7 over 3, but not a negative 7. A negative 1 over 3? No. A 5 over 3? No. An 11 over 3? Yes. All right, now I've already gone past all these guys, so now I'm going to go back to my original thing here, which is my negative 31 over 3. Let's go ahead and get that as fraction form. And instead of adding 2, I'm going to take away 2. Negative 37 over 3. Negative 43 over 3. And there you go. That's all 3 of them. All right, select a pair of angles that are coterminal with 354 degrees. What that means is you plus or minus 360 degrees. That's all it means. Now, if I had 354 and I took away 360, I'd have negative 6. So there's a negative 6 there, and there. So that's obviously one of them. You would not get negative 354. It's not going to happen, because if you have negative 6 and you take away 360 again, oops, if you have a negative 6 and you take away 360 again, you've already gone as far negative as the answer choices allow. So the smallest negative angle is going to be negative 6. Now let's go back to our 354 and let's add 360 and hope we run into a positive angle. I don't see 714, so let's do it again. And there's 1074. But I see 1074 there, but that angle is a big no-no, right? 360 is a no-no, never saw her. Well, let's add it again. 1434. Choice C. Not a hard problem. I will be right back. I heard my phone go off. Probably the wife. All right, find the secant of 23 pi over 4. I'll show you 2 ways to do this thing. All right. First off, make this thing a degree. We know that pi is worth 180. So let's see how many degrees that is. We got 23 We got 180 over a 4. It's 1,035 degrees. And I don't really feel like drawing a 1,035 degree angle, so I'm just going to take away 360 a few times and see what I get until I get something smaller. 315, hey, that's doable. I know how to draw a 315 degree angle. Do you? You should. That's going to rotate right there. Now, you have covered all of a circle but 45 degrees, and that 45 degrees is a big deal because she's the reference angle. And I asked you to memorize some stuff. 45, 45, 90 there. Opposite of a 45 degree angle is a 1. Adjacent to a 45 degree angle is also 1. Hypotenuse is root 2. That guy is negative because it's falling. If I do classic trig, which is triangular approach, I'm doing ha. Hypotenuse over adjacent. So it's just root 2 over 1, which is root 2. So that's one way of doing this problem. All right. Another way I might do this problem, do remember that I said that this was the same thing as the secant of 315 degrees. So I'm thinking about the unit circle, all right, which by the way has a radius of 1. I am looking, my eyeballs are looking at 315 degrees. That's just a throwback there for that video guy that you were watching on the EOC practice stuff. But at 315 degrees, you see the ordered pair root 2 over 2 and then a negative root 2 over 2. All right, circular approach. Secant of any angle is r over x. Unit circle, radius is 1, the x-coordinates root 2 over 2. Clean up, this would be 1 times 2 over root 2, which is just 2 over root 2. Keep cleaning up, multiply top and bottom by root 2 over root 2. You get 2 root 2 over 2, which is just root 2. All right, now, this would do you some good if this is multiple choice. I'm not saying it is, I'm not saying it ain't. But secant is also the reciprocal of cosine. So I can think of this as 1 over the cosine of 315. Let's put my calculator in degree mode. Okay. I could also think of it as 1 over the cosine of 23 pi over 4. But then I just put it in radian mode. It doesn't really matter. They're the same. 1 divided by the cosine of 315 degrees is this funky looking decimal right there, which is something that I've seen a couple million times in my life. It's root 2. So, there you go. Showed you 3 ways to come up with the answer to that one. Convert negative 1.87 radians into a degree, and you just do that really simple by multiplying by 180 degrees over a pi. Like, this is such an easy problem, and everybody should get it right, but no, it ain't gonna happen. I say probably 60% of the student body is gonna get it right, even though the formula's on the answer document, still gonna be missed. Prove me wrong. It's about 107.14 degrees. 75 degrees into a radian. Well, we just go the other way around. We multiply by pi over 180. That's what we do. We'll do this in exact form. Let's just take 75 times 1 over 180. You know, I'm just doing this to reduce the fraction real quick. It's 5/12. Don't forget about pi. Or I might just have you actually do rads. Or it's about 1.31 rad. I don't remember which one I have it on here. I don't. All right. Be right back. All right, so we have a crow, the guardian of the underworld, right? Crow keeps looking at you from the top of a building. The crow, which actually they are very intelligent, they can be taught several things, estimates the angle of depression to be 19 degrees. So does the crow know more than you do? Like, do you know what an angle of depression is? And estimates that you are 1,200 feet from the building. How tall is the building? All right, so here's my building. Buildings do form right angles with the ground. The crow is at the top of the building, forming a 19-degree angle of depression, which is actually formed with the horizon. Now, due to a lesson in geometry about alternate interior angles, this angle is congruent to that angle. That's called alternate interior angles. It turns out that the angle of depression is congruent to the angle of elevation. So if I have 19 degrees there, I have 19 degrees here. Now the crow thinks you're 1,200 foot from the building. How tall is the building? We'll call that H for height. It's got to stand for something, right? All right, let's talk about our relationships. H is opposite of the 19-degree angle, and 1,200 is adjacent to the 19-degree angle. So we're thinking about good old SOHCAHTOA, and I've got to be this guy right here, the tangent ratio. The tangent of 19 degrees must equal opposite, which is H, over 1,200. And it's an easy thing to do, bruh. You're just going to multiply both sides by 1,200, and then you can go push buttons in a calculator. Or I might just have it written out like this. This could be the answer. Right here. That could be it. I don't know. I don't remember. 1,200 tangents of 19 degrees. It says the building is tall, 413.2 foot. So the height is about 413 feet. Pretty tall building. All right, what do we got here? If the secant of beta is a negative squirt 2 and beta lies between 0 and 2 pi, what is the measure of beta? All right. Old school trig. All schools torture children. Secant, think about cosine. This is negative here and here. Cosine is x, right? And secant is the reciprocal, so it's negative where x is negative. That's how that works. I am going to draw triangles in these quadrants. And I'm going to put what's called beta prime here. Now, my ratio, if I wrote it, could be given as negative square root of 2 over 1. The secant ratio is the funny guy ha. So the hypotenuse is going to be root 2. Hypotenuses are never negative. It's the adjacent length that's 1. And this is a pattern you're supposed to know. 1, 1, root 2. This measure of that angle is 45 degrees, and she is a reference angle. This is actually beta. Always start on the positive x-axis, rotate to a terminal side. So one of my betas is going to be the straight angle of 180 degrees minus 45 degrees, which is 135 degrees. I do want these in pi rad, so if you memorized it, cool. If you didn't, it's also cool. You multiply by pi over 180, and what do you get here? You get 3 pi over 4, because that's what it is on the circle. Notice I'm talking about the circle. You could answer this thing with a circle to some degree. All right, now beta 2 would be down here. And I'm just going to draw an angle down here. And I already know the pattern up here. If this was 45 degrees, this is 45 degrees. Now this would actually be beta 2, positive x-axis to rotation to the terminal side. It is a straight angle of 180 or a semicircle of 180 plus 45. And that's going to be 225 degrees. And again, if I've memorized the unit circle, I don't have to do this step. But 225 as a pi rad ought to be 5 pi over 4. Feel free to check me on that. You know, push the buttons in your calculator, kids. I guess I should show you how to do that because you won't push buttons in a calculator. You can't spend your whole life expecting learning to be what somebody else is telling you. Like, you got to do it. 1.25, math enter. 5/4. Don't forget about pi. So there's your two answers. And that's all the extra review I did. This is just something small for 7th period. But maybe the other classes can use it too.